Okay, so by now, if you already come to this thing called possibility diagram, you should already have an idea on what is a probability tree diagram. So you can think of this possibility diagram as an extension of the tree diagram. So what do I mean by an extension? So for example, I'm giving you, let's look at this example first. So a box contains 6 identical cards. So you need to be able to see that it's a kind of physical card. Okay, because later on we're going to do it in terms of replacement or without replacement. So in this question, we're going to do it with a replacement. So imagine here you got 6 cards and they are labeled 1 to 6. So, and I'm going to draw 2 cards with replacement. If I'm going to do this as a tree diagram, it will look something like this. So it will look something like, what can the first card be? It will be, the first card can be 1, 2, 3, 4, 5, 6. So these are the possibility for the first card. And then you're going to return the first card, and then you draw a second card. So by the time you go to the second card, it will be something like this. 1, 2, 3, 4, 5, 6. So the same thing goes for here. So here it could be 1, 2, 3, 4, 5, 6. So it's quite difficult to branch out because there are too many options already, too many possibilities. So if you insist on doing it as a tree diagram, it will look quite messy. But the idea is the same thing. So it's just that we are going to put this messy tree diagram onto a table instead. Okay, so we're going to translate this whole idea onto a table. So we call it a possibility diagram. We can also see the sample space here. So for example here, so how do we arrange it, right? So you can take this as the option for the first card. So these are the option for the first card. And then this can be the option for the second card. Okay, so this will be the option for the second card. So if you want to swap it the other way around, that's fine. The vertical one can be the first card, the horizontal one can be the second card. It doesn't matter. So when you draw it, right, you will have the option of, let's say, 1, 1. Or it can be the first card is a 1 and then the second card is a 2. Or it can be the first card is 1 and the second card is a 3. So this will be the possibility. So that means this will be the column where the first card is 1. So it can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 4, 1, 5, and 1, 6. So or it can happen, maybe your first card is a 2. So it can be a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay, so basically I'm doing the same. I'm doing like what a tree diagram will have. So for example, if this is a 1, I'll get 1, 2, 3, 4, 5, 6. So the outcome will be 1, 1. The outcome will be 1, 2. The outcome can be 1, 3. The outcome can be 1, 4. So I'm actually doing whatever a tree diagram can do as well. So if I do it this way, it will be 2, 1, 2, 2, 2, 3. So essentially, I'm doing it like a tree diagram, but it's just that I organize it on a table format. So if you continue, this will be all the possible outcome. So in a way, the possible outcome is something like your sample space as well. Okay, so just be a bit patient to write out all the outcome. So usually it's not very tedious. It's quite possible that you can write it out. So at the end of writing everything out, you should look at the total number of possible outcomes. So you should look at the total number of possible outcomes. So if you look, there are total outcome. There are 36 of them. So which means if you have 6 identical cards, if you try to draw 2 with replacement, there are 36 possible outcomes that can happen. Okay, so if you want the probability where both are even number, the denominator will be 36 because you have 36 chances because of the 36 possible outcome. Then from there, your job is to look at the outcome where both are even. So both are even. You can circle the outcome to facilitate your counting. So both are even. So if you count, there are 9 possibility, 9 outcome of both even numbers out of 36. So the probability will be 1/4. So that is how you lay out a complex tree diagram into a table, because there are just too many outcomes if I'm going to be using the tree diagram. Okay, so if you understand this, we are going to be going to the next example, which is exactly like the first one, except that we are not going to replace a card. So we are not going to replace a card. So I'm still having the 6 physical card. So I still have the 6 physical card. But right now, I'm going to do it without replacement. So again, right, if you want to try it as a tree diagram, it will look like this. So if you try it as a tree diagram, it will look like this. So you already taken 1 as a first card. So this card will not be replaced already. So that means, right, in your next card, you only left with 5 choices, which is 2, 3, 4, 5, 6. So in this case, right, you will have the possible outcome like this. So you realize that 1, 1 is not possible because the first card, the number 1 card that has been taken out, is not going to be put back. Okay, so if I go to the second one, the number 2 is taken. So I'll be left with number 1. 2 is taken. So 3, 4, 5, 6. So I'm left with 5 possible cards. So it will be something like 2, 1, 2, 3, 2, 4, 2, 5, and 2, 6. You realize that 2, 2 is also not possible because the first card that is taken is not going to replace that. So it's totally not possible already. So you will expect that if I try, that means, right, if I do it the same way, like my previous question, this is the first card. And this part is my second card. So first of all, if you understand the idea that you cannot replace the first card, so you cannot get 1, 1, you also cannot get 2, 2. Okay, because the first card that you've taken is not going to be replaced. So you will realize that all these are not a valid option. So it's not possible. So you will be left with 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 3. So you should have the idea that right now, because of the without replacement, the total number has been reduced. So the total possible outcome has been reduced. But you still will need to be writing out all the possible outcomes. Because eventually they can ask you a variety of questions regarding this possible outcome. So you do need to write out. Sometimes they will just ask you, what is the possibility that the 2 cards will add up to a odd number, or the 2 cards will add up to an even number. So you actually got to take a look at the actual outcome. Okay, so write out everything. So it's the same idea of branching, but it's without replacement. That means the first card, whichever first card that is taken out, right, it's not being replaced. So in this case, the total outcome is lesser than our previous example. The previous example was with replacement, so there's 36 outcome. But if you count it now, you realize that there's only 30 outcome. So if I'm going to do the same probability, my denominator will be a 30. So you still go and count how many outcomes will be both even number. So both even number, you count as per normal, go and circle it up. You realize that significantly you also got fewer outcome where both cards are even. So you got 6. So the final probability is 1/5. So with or without replacement, it affects the total outcome, and also it affects the possible outcome that we are looking at as well. Okay, so the idea that we are putting our possibility or sample space or the possible outcome on something like this is called a possibility diagram. Okay, so it is an extension of complex tree diagram. So sometimes it's really quite complex if you're going to branch out too many from a tree diagram. So we just put it as in a table formats. So in the same way, okay, we can also do it, instead of doing it in a box, we can use dots. We can use like a grid, like this example. So this one is like throwing a standard 6-sided die. So when you throw a dice, you'll be 1, 2, 3, 4, 5, 6. So if you're going to throw 2 dice, okay, the 2 dice, right, this one it's not a matter of with or without replacement. You imagine you throw 2 dice. What are the outcome? Okay, if you have played Monopoly or games that involve dice, you will know that there's a lot of outcome. So you can have both 1. Okay, both your dice can show 1, or you can show 1, 2. It can show 1, 3. It can show 1, 4. It can show 1, 5. It can show 1, 6. So we can arrange them in a dot, using dot. So for example, this dot is like 1, 1. This dot is like a 1, 2. 1, 3, 1, 4, 1, 5, 1, 6. Okay, so we use the dots to represent. So each dot is a possible outcome. Okay, so this diagram has been dotted out already. So it is the same idea. So in this case, there are a total possible outcome of 36. So when you throw a dice, 2 dice, there are 36 possible outcomes. Okay, so from these 36 outcomes, sometimes, they will ask different probability question regarding this. Okay, so for example, they can ask what the probability that both dice add up to more than 10. More than 10 means 11 and 12. So you got to circle the option that is 11. So this one will add up to 11 because this one is 5, 6. Okay, this one will also add up to 11 because this is a 6, 5. This one will add up to a 12 because this is a 6, 6. Okay, so if you go and count the others, you can take a look whether does it add up or not. So out of the 36 outcome, there's only 3 that can add up to more than 10. So it will be 3 out of 36. So the possibility diagram can be in a form of a grid. We use dots to represent. And again, the total outcome is important. Then you see what the question is asking and count carefully. So a lot of times for questions on possibility diagram, sometimes it's because of counting. Students count wrongly, and then they got the wrong probability. Okay, so this is another way that we do probability using a possibility diagram when the tree diagram get more complex.